Hi everyone, in this video I'm going to demonstrate how to regenerate the transfer functions using Matlab, or more precisely we are going to declare a transfer function variable in Matlab. We will look at two typical examples that we normally see in the context of the control system engineering. The first one, having the complex variable j omega, which is very commonly seen in the frequency domain analysis. But in terms of the Matlab, what we have to do is to replace j omega with s for our ease of generating the transfer function. And then we are going to discuss the first method using the transfer function command. And transfer function command, we have to represent this form, into this polynomial form. So what we have to do is actually just to expand this transfer function. And eventually we will have a 10s plus 30 divided by s power 4 plus 3s cubed plus 4s squared plus 4s. So what we have to do now is to actually enter the coefficients of the numerator and denominator respectively into the transfer function command. So let's do it in Matlab. The transfer function command here takes in two parameters. The first one is b. B represents the matrix that is actually containing all the coefficients in the numerator, coefficients of the s term. If we look at this transfer function in this example, we have 10s plus 30. Hence, the b will take in two numbers, 10 and 30. So remember, it will start from the highest power of s until s power 0. While a, we will have 1, 3, 4, s, and remember to put a 0 behind to represent the 0 s power of 0. So 1, 3, 4, 4 correspond to s power 4 plus 3s cubed plus 4s squared plus 4s. And lastly, the 0 represents the s power of 0. And hit enter, and there you go. Let's say in this example, you do not wish to actually do this tedious mathematical expansion work, and you would just like to type whatever that you see over here. You can also do this step. You just declare the s variable as the transfer function variable. So you see s equals to continuous time transfer function. And next, what you have to do is just to type according to what you have seen. So you have a 10 to multiply of s plus 3 divided by s multiply s plus 2 and then multiply s squared plus plus s plus 2. Close bracket. And you will eventually be getting the same thing again. So in this way, you can just minimize your calculation work. We go to example number 2. And you can see here, example 2, is actually in the pole 0 form. That means all the terms are actually nicely being factored into their poles and zeros accordingly. So in this case, we will be using another command called 0 pole gain. So 0 pole gain takes in three parameters. First one is the 0, followed by the pole, and lastly by the gain. If you look at example 2, we are actually having 1, 0 at minus 100. So we will just put it as minus 100. And followed by 3 poles. The first one located at the 0 origin, followed by negative 10 and negative 40. And lastly, we have a forward gain of 300. And there you go. So this is the transfer function g. If you like to interchange between the 0 pole gain form and the transfer function form, what you can do is that you just type tf equals to tfg, where this g is originally in other forms. It could be in a 0 pole gain. And there you go. So you are having now the expanded form already. So that is what I want to share for in this video. Thank you very much for watching. Bye.